Great. All right. So today we have our guest speaker is Jungwon Seo, and he's going to be talking to us about how we can better share data. So I give it to you.
Okay, thank you, Lisa. Hi, thank you for coming. And my name is Jungwon Seo. I'm a PhD candidate in ID department and at University of Stavanger. And I'm currently working for NCS 2030, especially for the work package 5. And people around me often ask me what I'm doing here is like, and I explain like this, like I'm building a blockchain powered distributed cloud platform where you can train machine learning models without sharing the data. But I don't really like this explanation because it sounds like some kind of startup CEO. But honestly, we need all of those technology. And so to understand why we need this technology, I'm gonna start with some brief like history and explanation of those technological development and talk about the challenge that we are facing in NCS 2030. So today's topics are going to be like from big data to blockchain. So first of all, like the most important thing is like the data and why do we have to store those data? And it depends on your industry and field. Some industry might have to, like they just have to store the data, like something like government-related organization or bank and hospital. That's what regulation demands for them. And also like some kind of like factory or manufacturing industry, they have to store the data in case something happens so that they can trace back where the problem is immediately. And some IT companies that we know very well, they are actually selling those data like through their like, product. And also like not only those kind of big companies, any kind of like product or service developing companies need to improve their product and process like continuously. That's why they have to store the data. And I just brought some example, like this is the process of like the manufacturing the semiconductor. And if they have like several like steps to finally like produce the like microchip. And if something goes wrong, we can't really find, if we don't save the data, we can't really find in which process we made the mistake. Because like this is the one factory that is manufacturing those tiny little like microchip, and their size is like a 520 meter and height is like 80 meter and width is like 270 meter. So it is not possible to manually dig in where the problem is. So that's why we need to store the data. And where shall we store the data? Like the most like familiar like software is like Excel. We can store a certain amount of data into Excel, but they have a critical limitation, which is you can only store 1 million rows, which is not really enough for those kind of like gigantic data like source. So then what about we use database like data like conventional database like MySQL is very good. Like that's what people know. But like yes, we can use this, but the problem is like those kind of like conventional databases highly rely on like single machine performance. Then like you can say that, oh, why don't you upgrade the machine? So let's say that the amount of data is the number of passengers and this computer is the car. And if you want to have more passengers, then you have to upgrade the car like this, and again, and again, and again, and again. So like at some point, like you can't really like realistically like upgrade your single machine. Like there are several reasons, and one of the reason is like physical like limitation, because like if you add more CPU or RAM into one single machine, at some point you have to invest more on the other like components like cooling system or power system as well. If you take a look at those like size of those like wheels, like as if the car becomes this big, the wheel should be ridiculously big to support this weight. So it's pretty much the same like limitation. And also like if the data is that important, if you store into one machine, if that one machine dies, you are going to lose all the data. So, and also that there are many other reasons. So instead of like upgrading the single machine vertically, we are gonna like connect many different machines, like to distribute those data to keep it safely and to overcome those limitations. So you can picture the train. So it can like the way that you store the data, you just simply connect more like car into this like a big train. So we call it like the original approach is like scaling up, and the train approach is like scale out. And but the challenge is like if you simply like just distribute those like the database, like then there will be a problem when you actually try to process those data. For example, like let's say that we have like 1 million rows, and we have like thousands of those distributed systems. And if you want to calculate, like, for example, Tom's average score, or like if you want to do some kind of sorting algorithm and extract the top 10 students, like then you first of all, you have to find where Tom is, and you have to like aggregate those information. And this will take more time than than the conventional approach. So that's why we need some kind of big data technologies. When we talk about big data, it's not just about the like certain amount of size, not just like 1,000 gigabyte is big data. It's more like the amount of data you can't really process in a reasonable time with a conventional approach. That's why you need those kind of like Spark or Hadoop or Elasticsearch kind of technology. And then you may think like, except those gigantic organizations, do we really need those technologies? Then like we didn't really need back in the day, but something happened in 2010, which was like smartphone came. So Steve Jobs brought smartphone and it became commercialized. And then suddenly like we start to have like 24/7 like data collector to all the populations in the world. So the way that he described the iPhone is like iPod plus phone plus the internet, but the way that I described the iPhone is like the data collector. Before the smartphone, like the way that data was produced and stored was like it was limited in a certain period of time, like for example, like after work or like during weekend. But after we start to have smartphone, like we keep using it until we fall asleep. So like the amount of data that are generated is much more than before. And so like after smartphone came, there are new businesses. Like some of the business they exist before and they moved to the mobile like application as well. And some of the services are starting from the mobile application. And what those companies proved were like if they store more data, then they can actually make it more profitable. Like because like most of their main business was advertisement. So what they wanted to do is like they want user to stay longer, and and also like to enhance the click like rate, they want to customize their advertisement. So it is important for them to recommend the relevant content for the individual users. So like eventually like starting from this advertisement field, many industry also realize that if you store more data, then they're gonna bring more revenue. And like also like there are 305 million startups are created each year, like globally, and of course most of them fail in the first year. But even though it's like 10%, like those companies will keep continue, and they at some point they have to apply those kind of big data technology because they're gonna have a lot of data to process, and at some point at the same time they have to continuously improve their product. So if you see this figure, like the amount of generated data is it keep increasing, and this is not cumulated amount of data. It's like each year's like the generated data. So and it will be more and more. That's what people are forecasting. So now we just simply cover the data part, why we need the data and how we can handle those kind of big amount of data. And where should we store the data? That's the next question. Like, do we have to like build our own data center and connect those all the like complex cables? No, we don't do that anymore. Like some industries still do, but like if you have choice, like most of people are choosing cloud computing. So one of the biggest cloud computing like provider is Amazon Web Services, and if you see their revenue, it keeps increasing. It's the important part of this like graph is not the amount of the revenue they are making, that the fact that it keeps increasing. So like compared to the conventional data center approach, now these days you just need to type number of like servers that you want to initiate, and just if you just click, then instantly in 5 minutes you will have like 1,000 servers that you want to operate. And if you use cloud, then how much data can you store like into those kind of cloud service? And what they are saying is actually unlimited. Like physically it's not possible. Like if you want to store more data, like eventually they're gonna like add more servers to store to provide the storage. So this is why they call it unlimited. And the reason that they can confidently say that it's unlimited is like if you go to their data center, this one like a single like kind of cabinet kind of look like thing is we call it rack. So there are like several servers into one rack, and there are many racks, and those are in those kind of data center, and they are everywhere in the world. And not only Amazon Web Services, but also Microsoft and Google Cloud. So there are enough space that we can store the data. And the important thing is like what kind of data and like how we process those data is. So we just like cover the cloud platform part as well. And let's say like that now we have like good technology to process the data and good infrastructure that we can unlimitedly like store the data. Then where do we use those data? Like it depends on your field, obviously. We are not going to cover all of those things. And the key purpose of those usage is like you want to detect something or predict something or optimize some kind of process. So that's the main purpose of using those data. And the ultimate goal is of course since it's engineering, what you want to do is like you want to drop the cost and maximize the outcome. And also like if you just like keep storing the data like and not using it, it's a constant cost. Like because the way they charge the like bill in for example in cloud service, like even though you don't really use those data, even though you don't really add more like new data anymore, still like the amount of data you are storing will be the way that they charge your like bills for the cloud service. So you need to find a way to use those data like wisely, otherwise you are going to keep losing money. Then how can we improve the performance that we said like prediction or like detection or optimization? Like we are going to use machine learning. And before we touch the machine learning part, I think it's important to differentiate between statistics and machine learning, because like some people still like think like, isn't machine learning just a part of a statistic, which is like partially true, but like the main difference of those two fields is like when you use statistics, you want to understand the data, and also you are going to use a sample data, not entire data. But when you use machine learning and you like it's like some when you want to make a like decision, that's when you use machine learning. And in machine learning field, you have to use a large amount of data. That's the main difference. And those machine learning technology has existed for a while, even before this kind of machine learning booms. And some of them are still widely used, but like those like conventional algorithms, like they didn't really meet the ordinary people's expectation, including neural network that we know. Because like their main limitation was they couldn't really digest all the data that we have stored. Like at some point, if you provide more data to this model, their performance will converge and they can't really take advantage of like big data that we say. And then suddenly like deep learning came, like which is machine learning with like deep neural network. So this is like architecture of a deep neural network. But before we touch the deep neural network, of course, we have to understand what neural network is. So traditional neural network looks like this, and the way that they work, if you put certain input data, then in the model part, they have some kind of like numbers that calculate the final output. So it can be multiplication. And if the final output is like, for example, between 0 to 0.5, then we will decide this is a dog. And if the final output is like between 0.5 and 1.0, then we will say this is a cat. So that's the way that neural network is working. So for example, like we provide the information of a certain cat with its age, and height, and weight, and the final output is 0.1, then it's wrong, right? Because it should be over 0.5. Then like the way that this machine learning algorithm like learns something new is like you have to let this model know that you made a wrong decision. So you have to adjust these numbers. So after that, then they adjust the number automatically by some calculation. And finally, you can make a right decision based on this input. So it can be a cat. So then how do they automatically learn this like numbers? Like this is something that we are not going to touch today. And there will be a bunch of mathematical like calculation behind. And deep neural network, like the difference is like there are like it depends on the perspective. Like from the architecture perspective, if you have more than one hidden layer, then we call it deep neural network. So the calculation will be more complex, and we assume that it will generate a better output. But the real definition of like deep neural network is like some kind of model that can recognize certain patterns by itself, even though we don't explicitly mention what kind of like pattern it needs to learn. So one of the like popular example of a deep neural network is convolutional neural network, and the way that they learn is like after several like computation, they can like automatically recognize those patterns. And I will just show the example. Like, for example, like from this deep neural network, like if you train some kind of model using this image data, and if you take some part of this like neural network and see how they see this picture, is like, as you can see, like they see, like sometimes they focus on the body part, sometimes they focus on those kind of leg part. So even though we didn't really say this is a horse, this is a body of the horse, this is the head of the horse, they can identify this important feature of this picture like human does. So this is the main like definition of a deep neural network. They can recognize certain patterns by itself. So like this technology exists, but of course, like to make it more scientific, you need a benchmark data set, and you need to make those kind of like you need to make those researchers to compete to achieve the better performance. So one of the like most popular like benchmark data set is ImageNet data set, and they have 1,000 labels and they have 14 million data. And it might look quite simple, like this is tree and this is dog, but the actual labels is quite complicated. For example, like this is not just a crab, this is a fiddler crab, and this is not just a crab, this is a rock crab. So like you have to even like differentiate whether it's a fiddler or rock. So it's also like even difficult for human. So like after like this data set was like published, like some people tried with their like model that they were underdeveloped, and the performance wasn't really that satisfying, like 28% or 26%, which is the error rate. And suddenly, like in 2012, like there was one model made a big shift of this performance, and which is called AlexNet, and they suddenly have a 16% error rate. And they realized, oh, what if we add more layers, then we can have a better performance. So if you take a look at those like red box, that's the number of layers this deep neural network has. So eventually they end up like 152 layers, and then this can perform better than human. So this is the human error line. So like after it has been proven, if you have more layers in your deep neural network, then you can make a better performing model. So and then later people kind of carried away and made several different like model like neural network, like adding more layers, and like, of course there was some kind of adjustment. And then sometimes people, then why don't we make a random neural network? So this is just one example. Yeah. So like after this, like the neural network like development, those kind of computer vision like field is kind of like conquered, which means that model can perform better than human. And also similar things happens in natural language processing. And if you take a look, this example is like that. This is the sentence, like the animal didn't cross the street because it was too tired. And in this case, it means the animal, right? Because the animal is tired. And there is another sentence, which is the only difference is like this last word. The animal didn't cross the street because it was too wide. And in this case, it should be the street, right? So like even though we didn't really explicitly mention this, it is the animal, this it is the street, this model can learn and they can associate those like which word is more relevant for the other word. And then like as you know, all of we know now, like ChatGPT kind of large language model is performing better. Of course, they are based on this like self-recognizing pattern like mechanism. So like after this development, now we can digest more data and all the data. Like this is the deep learning algorithms performance. Like if you feed more data, then you can achieve better performance compared to the traditional ML algorithm. So like this is the movie I, Robot. I'm not sure if you guys remember this, but like in 2004, like there was a scene. It was very like shocking at that time for me. Like the Will Smith asked like if a robot can write a symphony or if a robot can like draw pictures or something, and the robot asked like, "Can you?" And Will Smith couldn't answer. And this was the AI in 2004. But like now in 2023, they actually can like write like make a music. They actually can like draw the paint, and they actually can like write any kind of like poem or a text-based like content. And some people may say like, oh, I have tested those like components, but they were not really great. But what I want to say is like, I don't know how to make music and I don't know how to draw paint. So at least they are better than ordinary people's performance. And this is one example that I tested. Like I just asked some AI, like generative AI that draw the picture and called Mid Journey. And I asked them to draw a Korean guy is having a presentation in Norway. And this is the result, which is like very realistic. You can't really differentiate whether it's a artificial or real picture from human. So this is the output that we like performance that we have now. So like if you take a look those kind of like technical trend, at some point those hype passed and like their popularity will start to decrease. But AI or machine learning experience those like decline trend, but like after those kind of large language model or generative model, now they are having second booster and having a second golden era of their time. So like when you talk about those kind of AI, like some people may kind of get scared, and of course I sometimes I get scared as well. And because like in those kind of tests, computer vision or natural language processing or recommender system or speech recognition or more other field, now AI actually performing better than normal human being. Like the reason that I said normal human is like of course, like artists can, like music artists can make better music, but like compared to normal human, AI can make better music now. So, but like if the reason that we start to get scared of those technology is like because we see those AI as a competitor of us. But like the way that I see these, like AI is actually some kind of tool that we can use. The only thing that we can win against those kind of AI technologies, like we have love and they don't have yet. But even though they have, then it's better. Like they're gonna love us and they're gonna make use their capability in like to for something that they love. So then it will be a real heaven. So now we cover the machine learning part as well, and we only have the blockchain part. So let's go for this like topic as well. So now we have a hardware and software to store infinite amount of data, and we have algorithms that can outperform human capability. So we are all good now, or are we good? Like so, those I'm not sure if you already forgot this scandal, but there was a scandal in 2018, the Facebook and Cambridge Analytica of this data breach scandal. And also like those kind of generative AI, like issuing new question to us, cause like when they train the model, they are using real humans work, like for example, paint, or it can be music, or it can be actual like text-based content. And like, who are we giving those like credit to those original author? That's another question. And once you publish your data online, then it's kind of like you are losing your data ownership. And even though you say that, oh, I don't really produce my data, but it happens in your like ordinary like activity in the web, like surfing. For example, like I searched my name and UIS in Google, and they show this kind of image, which is from LinkedIn. But like my current profile image is this. So what it means is not just like, oh, maybe they haven't updated the new profile yet. It's not like that simple, like, which means like, even though I changed, which means I deleted my previous image, the Google still stored my previous image, and we never know if they're gonna ever delete this image or not. So we are not really the owner of our data. So the dilemma here is like in the previous slide, I talk about those kind of technological improvement. Now we can do anything like kind of thing, but like we need more data to build a better model. But like we should move the data to protect our privacy or data ownership. So that's the dilemma that we are facing. And for to tackle this challenge, what we are proposing is like we are using federative learning kind of approach. So federative learning approach is simply like we are not going to move the data, we are going to move the model, like so that we can make a one big good model while like taking advantage of this like data itself. And the way that federative learning is like this, like they are moving the model, and we want to know how does the model look like. And I was talking about those kind of deep neural network, and they have several layers, and this is the architecture of the model. So you have like 4 different layers, and that's the like layer that we are saying. And the way that we are implementing this architecture is like, if you code like this, then they will have those layers. And what they eventually have inside is those kind of numerical data. So when we train the model, and those numbers will keep changing, and at some point, like if performance starts to get converges, and that's the model that we want to share. So the federated learning, the way that federated learning is like working is like, first you have a server and you have each client, and each client holds their data. It can be the company, or it can be your mobile devices as well. And when first you like distribute your original model, and each client will start to train using their local data. And then they send those locally trained model again. And from the central server, they aggregate this model and make global model and redistribute this. And they keep repeating this process. And eventually you are gonna take advantage of all those data, but you don't really see those data. So that the client can keep their like privacy and can keep their data ownership. And also like some data is too big. So it's not really efficient to move around those data. Like even though you don't really care about the privacy, like if it's like 1 terabyte of amount of data, then it's better to move the model than the data. So then how do you aggregate and make a global model? Like, do they need some kind of special trick? But surprisingly, it's very simple. You just need to like summarize all the like numerical metrics that I showed in the previous slide, and you just average it. And this is a global model, and surprisingly, they are working very well. And we prepared one example for this federated learning approach, which was done by our research group. And what we want to do is like, we want to predict the proper rate of penetration to drill this F10 well. And we are thinking, if we use the well, like previous data from different wells, can we make a better like prediction of this ROP rate of penetration for F10? So we did a research, and of course, like if you use the other like the wells data, then it shows the better stable, and it shows more stable and better performance. So like the problem in this like oil platform is like it's not owned by single like companies who are operating this oil platform. They are operated by different companies, which means like it's kind of challenging for them to share data to make a better decision for their own well like production. So like if they can collaborate, and even though they don't have to share the data, if they can make a better model by taking advantage of those like data using federated learning, and we can drop the emission and maximize the outcome. That's what we are seeing the potential of this federated learning approach in oil and energy industry. Okay, so but like still we didn't really touch the blockchain part, and now we are going to talk about why we need blockchain for this collaboration. So like the challenge of this collaboration is like, to run this federated learning, we need to build and operate those kind of platform. And the question is, who's gonna build and who's gonna operate those platforms? Like for example, if like each company will develop their own like platform and integrate later, like then you can't really trust each other, because like you never see how they implement it, and you never know how they're gonna like react to your interaction as well. And also like, even though you put another one central authority, then like the question is like, is that fair enough that they can like orchestrate this collaboration? So we need a solution that is decentralized and distributed and transparent and immutable, which means you can't really change the final like updated data. So we need the blockchain, not Bitcoin. So like what we want to do is like for this collaboration, because each client they have equal like power. So we want to decentralize their way of communicating, not centralized way. So for this decentralized like network, we need a one common like database or interactive like hub, like which like that. For that we are gonna use blockchain. So we are gonna decentralize those communication using blockchain technology. And blockchain itself is very complicated and there are many things to talk about, but we are not going to touch this part today's like seminar. And the way that I describe blockchain for the non-technical people is a database that no single entity can dominate. So like when we are gonna run those kind of federated learning process, we are gonna record all those kind of interaction, like which data has been requested and which data has been used, and which like who owns those data and who used those data. And once those transactions are recorded, it's not able to like update later. So we can see later like if there was a like wrong interaction that they shouldn't happen. And also, like if we use blockchain, like we can also implement those kind of incentive mechanism. As I said, like before, for example, in those kind of generative model, like they are just using others' data, and we can't really prove if my data has been used or not. And if you can prove and if you can give the right credit for the original data generator, then it like those kind of like machine learning or big data industry will be more encouraged to generate our original data. So that's the another like benefit of using blockchain. So we also cover this blockchain part. So now I can say that I'm building a blockchain-powered distributed cloud platform where you can train machine learning models without sharing the data. And eventually what we want to build through this technology is like federated knowledge cloud, which you can like similar domain like organization can collaborate without worrying about their like data privacy or data ownership. So if they can collaborate together, then of course, like the fundamental like idea of machine learning is like if you have more data, you can make better performing model. So if you can collaborate more, then we can build a better model as well. So we can like, for example, like for energy industry, they can build the energy knowledge cloud, or for the medical field, they can build a medical knowledge cloud as well. And not only for those kind of like federated learning, we can also collaborate differently. And here is the example that I brought from the TV series called Silicon Valley. And in this series, he made some kind of like image classification model, which it can identify whether it is hot dog or not hot dog. And it doesn't like identify whether it's a pizza or like other thing. It just say not hot dog. So it was very funny scene. And the surprising thing is he sold this company in this series. He sold this technology to this like video streaming company because of what this video streaming company was struggling at the time. Because like, there are so many like weird people who are showing their hot dogs. So they want to automatically identify those people and ban those users. So they use this hot dog, not hot dog technology to identify this. And this sounds like a joke, but actually this is a official technology that we have like called the transfer learning. So the challenge here is like not all industry or organization has collected and labeled their data, which means they don't have enough data to train their model. So in this case, you can actually use model that was trained using other big amount of data and take those model to adapt your specified data as well. That is called the transfer learning. So even though you use just kind of horse or like cat or dog kind of data, it can perform better, like with small amount of medical data set. So that's the technology called transfer learning. And also like we can imagine like those kind of situation, like this is a data set from the NFL like game. And what they wanted to do is like they want to detect this kind of helmet collision so that after the game they can take care of those kind of players more, like because like they might have some kind of damage in their head. So if he develop some kind of model to identify those helmet or to identify those kind of like collision, we can also apply this in the industrial side if there is some kind of like accident that human couldn't really like recognize automatically. So that's the one use case that I can imagine. And another thing is like left image is like the picture from the satellite and the right image is like picture from the microscope. So if we want to do some kind of task to identify some kind of object in the desert or identify some kind of object in the skin, we can also like use transfer learning approach. Of course, it depends on depends on the amount of data that they hold. So if one of them hold more data, then you can also use transfer learning approach. And what I wanted to say through this slide is like there are so many ways or so many potential to collaborate, but we don't know each other's each other's field. So we don't really know if it's applicable or not. So the most important collaboration is like the actual collaboration between those two human beings. And if you cannot collaborate well enough, like the technology will follow later. So that's what I wanted to say for this presentation. So thank you for the participation, and this is the end of the slide.